Okay, this is guided practice for AM objectives 96 and 97, and we're still dealing with radicals at the beginning, and then we actually have to solve equations that use square roots to get our solution. So, starting with number 1, I got the square root of 2 times the square root of 10. And neither one of these are perfect squares underneath the radical, but what I can do is combine these under one radical, and that's 2 times 10 under one radical, or one square root. So 2 times 10 is 20, so all I'm doing is kind of maneuver things around with the rules that I've learned in class in order to simplify this idea. So 2 times 10 is 20, so I have the square root of 20. Now, I do have a perfect square underneath here if I break this 20 down to 4 times 5. Now, 5 is not a perfect square, and I can't get another perfect square outside of 5. But 4 is a perfect square, so I can bring that out in front of my radical as 2, because 2 times 2 is 4. So I have 2 square roots of 5. So number 1 is C. Number 2 says the square root of 30 times 3 square roots of 36. Now this one's kind of a simple idea. I can just kind of start simplifying some things. I have the square root of 30 times 3 times the square root of 36 is 6. Now 3 times 6 is 18. So what I have here is the square root of 30 times 18. That's the times sign right there. Now, square root of 30 times 18 is the same thing as 18 times the square root of 30. And I don't have to put this times sign in there. I can just say 18 square roots of 30. Sorry, my 3 looks a little bad there. But it's 18 square roots of 30, which is B. Moving on to number 3. Number 3 says 3 square roots of 180 times 4 square roots of 30. Now this one starts looking a little complicated, but it's not so bad. I'm just going to rearrange things. On the outside I have a 3 and a 4, so let's put those together. 3 times 4 times, and then let's combine my square roots. I got 180 times 30. Now I'm going to simplify this a little further. I got 3 times 4 times 180 times 30 is 5,400. Now my goal here is to see if there's any squares, any perfect squares that I can pull out from under this radical. Well, anytime I see something ending in 2 zeros, I know that's something times 100, so I can break that down pretty easy. 100 is a perfect square. So this quite quickly I can say is 54 times 100. 100 is a perfect square that I can pull out of the radical as 10, so I have 3 times 4 times 10 square roots of 54. Now, there's also a 9 under here that I could pull out, and I could have pulled out as 900, but I didn't see that the first time. I could have pulled it all out at one time, but what I have to do now is realize that 6 times 9, or 9 times 6 is 54, so that's 3 times 4 times 10 times the square root of 9 times 6. Pull the 9 out as a 3. Now I have 3 times 4 times 10 times 3 times the square root of 6. Now I can't do anything else under this radical. That's it. I've gotten all the perfect squares out, so I just go through here and I multiply 3 times 4 times 10 times 3. Stick that in my calculator, and that should give me 360 square roots of 6. It's going to be B. Moving on to number 4. Number 4 says 5 square roots of 20 times 2 square roots of 6. Let me go ahead and combine these like I did last time. I have 5 times 2 times the square root of 20 times 6. And I have 5 times 2 times the square root of 120. I know that I can break that 120 down to 4 times 30, and I can remove that 4 as a 2, so I have 5 times 2 times 2 square root of 30. Put that times there. And then 30 is as low as it'll go. I can't pull any more squares out of a 30. So I got 5 times 2 times 2, which is 20 square roots of 30. So number 4, 20 square roots of 30 is choice A. Look at number 5. Number 5 has a solving an equation, and the equation has a x squared in it, and to undo that I'm going to have to use these rules that I've learned about perfect squares or square roots. So it's 36 x squared minus 49 equals 0. Now I start this off just like we've been doing for months now, solving the equation. Isolate the variable term by inverse operations, so that means I got to add a 49 to both sides. This goes away. I got 36 x squared equals 49. Now I got to isolate my variable. I've got my variable term isolated. Now I isolate my variable. I'm going to divide both sides by 36. That goes to 1, so I have x squared equals 49 over 36. Now I got to get rid of this square, so I'm going to take the square root of both sides. If I do it to one side, I got to do it to the other side. And remember, once I take the square root, I have two answers. I got the plus and the negative of whatever answer I get. So x times x is x squared, so this simplifies to x. Square root of 49 is 7, and the square root of 36 is 6. So my answer is plus or positive or negative 7 over 6. So that's going to be D. Looking at number 6, I hope I have enough room here. Number 6 says x squared minus 45 equals 0. Again, I'm going to use inverse operations to isolate this variable term, so I have to add. It's been subtracted, so I'm going to add a 45 to both sides. This goes to 0. Now I got to get rid of the squared by taking the square root of both sides. Remember, it's going to be a plus or positive or negative answer now that I've taken the square root. X times x is x squared, so that goes to x. Positive or negative square root of 45. I can simplify that square root of 45 because that's the same thing as 9 times 5, and then I can pull the 9 out as a 3, so I have x equals positive or negative 3 square roots of 5, and that is choice B. Number 7, x squared equals 49. This is pretty simple. All I have to do is take the square root of both sides, and remember that it's going to be a positive or negative answer. So square root of x squared is x. Square root of 49 is 7, because 7 times 7 is 49. So that's positive or negative 7. That's going to be C. And then number 8, x squared plus 12 equals 0. Subtract a 12 from both sides. This goes to 0. I have x squared equals negative 12. Take the square root of both sides. X equals, there's nothing times itself that can give me a negative answer. Remember, this can't happen. Can't have a negative under the radical. So that means that no real solution. So in this case, I can't, like I said, when I have a negative underneath the square root, that's not allowed. I can't have that. There's nothing times itself that'll give me a negative answer. So the correct answer for number 8 is choice D. No real solution. And that's your examples from the guided practice, AM objectives 96 and 97.